Solve each of these equations. Now, some of these times this will show up on an exam and they'll say, solve it algebraically. And what they want to see is, can you use the formula for permutations to solve an equation? Now, the formula for NP2 would be n factorial over n minus 2 factorial equals 56. And so what we need to learn is, how do you get rid of a factorial sign with algebra? Well, if these were nice numbers, like if I had 10 factorial over 8 factorial, you could simplify this. How would you simplify it? Well, you'd say, I know that 10 factorial is 10 times 9 times 8 all the way down to 1, but I'm going to stop at 8 and just put an exclamation mark there because 8 factorial would mean all the way down to 1, and I have an 8 factorial on the bottom, so that would allow me to cancel those out. And by canceling those out, I cancel out the factorial sign. Does that make sense with real numbers? And with real numbers, which one did I expand? I expanded the bigger number, because eventually I'll get to the smaller number. So when we get to variables, the first thing you have to decide is which is bigger, the n factorial or the n minus 2 factorial. And in this case, the n factorial is bigger. So we start expanding it with the definition. And n factorial would just mean if it's 10, it's 10 times 9 times 8. It's 15, it's 15 times 14 times 13. If it's n, it would be n times what would be next? 1 less. What's 1 less than n? N minus 1. And then you would multiply by 1 less. What's 1 less than n minus 1? N minus 2. And at n minus 2, I'm going to add an exclamation mark because that's what I have on the bottom, still equal to 56. And those n minus 2's, along with that factorial, can cancel out. And what we're left with is n squared minus n equals 56. Well, this is a quadratic equation. You guys are getting good at these, making one side equal to 0 and factoring. So n squared minus n minus 56 is going to be 8 and 7 minus 8 and plus 7. So we get two answers for n. N equals 8 and n equals negative 7. Now, when we learned about factorials for the first time, our definition of factorial was only if the values were positive whole numbers, and we also had a special definition that said 0 factorial was equal to 1. So after you get your answers, anytime you have an equation with factorials, you're going to have to check to make sure you don't have any negative factorials. If I plug in 8, 8 factorial is fine. 8 minus 2 factorial is fine. 8 is okay. But if I plug in negative 7, I'll have a negative factorial, which doesn't make sense, and so we have to cancel that one out. And the only answer is n equals 8. So this is how you would solve this algebraically. A non-algebraic answer, if you use spaces, for example, NP2, the 2 means that there would have to be 2 spaces equal to 56. What two numbers that are consecutive multiply to give you 56? 8 times 7. And so you would know that n would have to be 8. Sure, that's a lot quicker. Unfortunately, most times they say you have to do it algebraically. But there are some questions like B. B might show up on a multiple choice part of an exam, but they won't ask for an algebraic solution to part B, because now you're finding the R, which is how many spaces. So if I was doing this one and I wanted equal to 20, I would ask, is 1 space enough? If I start with 5. Is 5 equal to 20? No. If I add another space, is 5 times 4 equal to 20? Yes. And so we needed 2 spaces, so R would have to be 2. So there are some that you have to do algebraically. I think there's one in the homework where you have to do it algebraically, and it ends up needing factoring a cubic equation. So you could try that one. You might want to guess and check first to see if you could figure it out and then try to factor it. But these ones solving for r are usually ones that you can just guess and check until you figure it out, or use the spaces as we did here. All right, so try question number 10.